Alright, so we're going to continue with looking at this fourth degree function. And we know that the points 1, 0 and negative 2, 0 are points where the function intersects the x-axis. Are there any other points where the function crosses the x-axis? And if so, we want to find them. And the first thing to think about is what are we really looking for? And of course, points where the function crosses the x-axis, those are roots or zeros. And so we know that we're looking for the roots, and we have two of them given to us because these are points where the function has a y value of 0, and so it crosses the x-axis and is a root. The next thing is, okay, what are we going to do in order to find the other two roots? And so let's just kind of consider what is it that we currently know. The first thing that we know is we know based on these two roots that we have two factors, two linear factors. And so there should be two more. I need 4 total, so there should be 2 more. Because in order for us to get a fourth degree polynomial, we know that we need to split it up into 4 linear factors. So at this point, what we have is we know that our function 3.8x to the fourth, and I'm not going to write the whole thing out, can be made up of 4 linear factors. And we just so happen to know 2 of them. So from the point 1, 0, we know that x minus 1 must be a factor, and from the point negative 2, 0, we know that x plus 2 must be a linear factor. And what we're trying to figure out is what are the other 2. And if we can find the other 2 using those factors, we can figure out the other 2 roots. Just to make sure that you understand where we're at, I want you to pause the video right now and tell yourself why it is that these are factors of our polynomial. Hopefully, in thinking about that, you realize that since when I plug in the x value of 1, I need to get 0, that this will be a factor because 1 minus 1 is 0, and similarly negative 2 plus 2 will also be 0. So what am I going to do to find my 2 missing factors? Pause the video right now, try and carry it out yourself, and then come back and check your work. So hopefully, just by thinking about regular algebra, we can see that we need to divide by both of the known factors. And so we're going to divide by x minus 1 and x plus 2. Notice that we could do this in 2 steps. We could divide by x minus 1 first and then divide by x plus 2, but we can kill 2 birds with 1 stone by dividing them both at the same time. And in order to do that, we're going to multiply these 2 factors out, and that will make it a little easier for us. So let's just show what we've got. When we multiply these out, we're going to have x squared plus x minus 2. And so that's what we're going to divide by. So to show where we're at, we have f of x is 3.8x to the fourth, and we're going to divide it by x squared plus x minus 2. And on the other side, we're also going to divide, and we're going to have x squared plus x minus 2 times both of our missing factors, and we're dividing, of course, by x squared plus x minus 2. And so these will cancel. I'll be left with exactly what it is that I'm looking for, which are going to be my 2 missing factors. So let me give us a little space here. And what we need to do is we need to now divide. So what we're going to have is our two missing factors, and on the other side we're going to have to actually divide this this polynomial. So I want you to go ahead and carry out the polynomial division on your own, and then come back and check, and we'll go over it together. So hopefully that went well. What we're going to have, alright, so let's go ahead and actually do that division, and I'm going to go through it rather quickly. 3.8x to the fourth. So just remember that we're thinking about, if I go back here, I'm thinking about what can I multiply x squared plus x minus 2 by to get my fourth degree function. So here I'm thinking about what can I multiply x squared plus x minus 2 by to get 3.8x to the fourth. In other words, how many times will x squared go into 3.8x to the fourth? And so first thing I notice, 3.8 times x, 3.8x squared, when I multiply that by x squared, I'm going to get 3.8x to the fourth. I'm going to multiply through, and I'm going to get 3.8x to the third minus 7.6x squared. Now, if you are unfamiliar, if you're a little confused as to why some of these things are happening, go back and watch the lesson where we go over this. We're going to subtract all of this, and so I'm going to multiply it in by my negative, 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 positive. Cancel, cancel. I'm going to end up with 3.8x cubed minus 41.8x squared minus 53.2 times x plus 91.2. X squared will go into 3.8x cubed, 3.8x times. Multiply through, I get 3.8x cubed plus 3.8x squared minus 7.6x, or 7.8x. Subtract once again. That's going to give me a negative, negative, and positive. Cancel there. I'm going to end up with negative 45.6x squared minus 45.6x plus 91.2. Decimal over there. When I multiply through, or excuse me, when I divide in, I'm going to get negative 45.6. And when I multiply through, it's going to give me negative 45.6x squared plus minus 45.6x plus 91.2. And that should be a good sign, because I know that's going to be exactly what I need, and I'm going to subtract that. It's going to become a positive, positive, and negative, and so everything will cancel, and I'm left with nothing. So stop there for a second, and then remind yourself, what is it that we've just found? Hopefully you realize what we have just found is the polynomial, which when I multiply by x squared plus x minus 2 will give me my quartic function. And so that is exactly what I've found. And so I know that these two remaining factors are equal to 3.8x squared plus 3.8x minus 45.6. Ran out of real estate there, but that's okay. And so you may be asking yourself, okay, well, why I need two factors. Why do I have this quadratic here? Well, you'll note that a quadratic has how many linear factors? It has two. And so what I need to do is I need to find out what are those two factors. So I want you to stop. I want you to think about what it is that you can do to find those, and then go ahead and execute. Right, hopefully you notice that there are a couple of different ways that I can find these two factors. The first thing I could do is I could actually factor this quadratic. And if you did that, that's fine. But there's also another way. So remember, what are these linear factors going to be linked to? Well, linear factors are going to tell you each one root. And so if you were to find the two roots of this quadratic polynomial, each root would give you a factor, just like we talked about at the beginning. So if you used the quadratic formula and set this equal to 0, you would be able to find both of the factors and therefore be able to factor our whole polynomial. I'm going to go ahead and factor, and the way I'm going to be able to do that is I'm going to notice here that I can factor out a 3.8 from my polynomial, and that's going to give me x squared plus x minus 12, and that is exactly going to be equal to 3.8 times x minus 3 times x plus 4. And that's going to be the remaining two factors that I needed. So if I wanted to write this polynomial, I could just take these two factors and put them where I originally had my two factors that I didn't know. Now I do know them. And so I can say that my entire polynomial is simply this. F of x is 3.8, I'm going to write that out front, x minus 3 times x plus 4 times x minus 1 times x plus 2. And so the roots of my polynomial are going to be corresponding to those linear factors. My roots are going to be, well, actually we should look at our question here. It says what are the points where the function crosses the x-axis. So I know those are roots, and I want to give them in point form. So the points are at 3, 0, at negative 4, 0, the two that I've already found that they give me at the beginning, 1, 0, and negative 2, 0. There you go.